Okay, at this point, I'd like to introduce our speaker for tonight. His name is Steve Moysan. Did I say it right?
Yep.
Steve and his wife, Dawn, who's also here with us, own a small farm, Frog Song Farm, where they raise corn, soybeans, some chickens, and of course, a bunch of bees. Steve started out with a single package of bees, and through self-sustainable practices and effective colony management, he grew that original colony to his current 40 colonies. He takes the responsibility of caring for his colonies very seriously and works diligently to maintain the health of his colonies. He started raising his own queens to be fully self-sufficient and has found this to be quite interesting and not nearly as difficult as expected. Steve enjoys helping others and mentors beginning beekeepers, as well as mentoring in the Hives for Heroes program. Steve is an active member of Lorain County Beekeepers Association, Ohio State Beekeepers Association, and director of the Medina County Beekeepers Association. In addition, he is the Ohio Department of Agriculture's Lorain County Bee Inspector. Please welcome Steve.
Thank you. Good evening, everyone. Thanks for being here. One thing I want to say is my presentations aren't just me speaking. Anytime you guys have any questions or comment, just raise your hand, stop me. And it's much better when it's interactive. So please don't hesitate to do that. This is a combination of beekeeping, pollination, and everything all kind of blended together. So I'll start with a little bit of introduction about myself, then a little bit about pollen plants and how the bees interact with the plants, nectar and honey and how the bees get the nectar, and then a little bit about bees and beekeeping in general, and then pollinators and bees and their interactions. Some people have concerns about honeybees and native bees and pollinators, so we'll touch about that a little bit. And then a little bit about what you can do to help pollinators overall. Okay, thanks. Sorry about that. This is my wife, Dawn, and myself. On the left, as beekeepers, and the right side as normal people. Some people say beekeepers are never normal. We started out, as he said, with just one package. This is what you get with a package of bees. There's a queen in there and about 10,000 bees. And it's literally a box of bees. And you put that in a hive and you start from scratch. And it's a lot like chicken math, where you kind of get addicted to it. And we started out with a single package. Then it quickly turned to 2, then to 3, and now I've got a whole bunch of them. So just like chickens, where you start with a couple and you get an entire coop full of them. Bees and flowers have built a symbiosis to turn around and work together to achieve combined goals for both of them. And the combination of both the bees and the flowers also equate to food for us as well. About 1/3 of all our food supply is pollinated by insects. Not all honeybees, but by insects in general, which is a large percentage of our food supply. So if we lose pollinators, we're in really bad shape. What do the bees get from the flowers? Their big thing is nectar. That's the... Okay. Sorry, I'll get it closer. Yeah. Yeah, I apologize. I'm not used to using a microphone. I have a clip on normally. There we go. The nectar is the main attractant for the bees. And the flowers turn around and have learned to generate the nectar to bring bees in, so they turn around and get the pollen and transfer the pollen for pollination. So the flowers want the pollen to be transferred for their benefit, so they turn around and generate nectar for the bees' benefit. So it's a really interesting symbiosis. And the flowers, of course, get the pollen transferred from the bees. I'll be touching on it shortly, but you can see the bees literally can get covered with pollen. There's actually electrostatic attraction that does that. The bees have special hairs on their front legs, so they can actually scrape it off, and then they pack it on their back legs to store and transport it. But when they get the pollen all over them and they fly to the next flower and so on, they're transporting the pollen across a great number of flowers. Things like pumpkins require an awful lot of pollination to turn around and get decent yields. So if you go by pumpkin fields, you'll take notice there's a lot of beehives out there. Without the additional pollination from the honeybees, the set on the flowers is greatly diminished and they get far, far fewer yield. Same thing with apples, other fruit trees, blueberries. Almonds, of course, is huge. They all require additional influx of honeybees for pollination. I should have asked this question before I got to it, but how many eyes does a bee have? The answer is actually 5. They've got the 2 main eyes on the side of their head, and these are compound eyes with about 5,000 lenses each, so you can see the small lenses there. But in the center, they've got 3 additional eyes called osceoli. Those actually see polarized light. Everything a bee does in terms of direction is based on the sun. So when a forager comes back and does a waggle dance inside the hive to tell everybody else where the good flowers are, she'll do a dance at a certain angle based on the position of the sun. These eyes here allow her to see the sun even when it's a cloudy day. When we can't see it, with the polarized light ability of these 3 eyes, the bee still can. So that's what they actually use the 3 eyes in the center of the head for, is for navigation purposes. They also see differently than we do. First off, they have the compound vision, so they see it in a broken up fashion rather than the way we do. Once they get closer, then they can see the detail. And they also see more in the ultraviolet spectrum, so the flowers actually appear totally different colors to them than they do to us. The other interesting thing is a red flower appears black to them. They can't see red. So if they have a whole bunch of red flowers out there, they don't see it. They just see black voids. The other interesting thing about the compound lens, when you go to swat a bee or a fly, and they always seem to avoid your hand, and they're like twice as fast as we are. The interesting thing about the lens structures, it turns around and picks up motion and trajectory so much better than our bifocal vision. And that's what allows them to avoid the swatting hand or the fly swatter. They could turn around and see the motion and direction much, much more effectively than we do. So even though they have a very tiny brain, they can outsmart the fly swatter very well. One of the things that people don't realize is there's also small electrical fields generated on flowers. The pollen has a very small electrical field, and you can see how it attaches to the bees electrostatically. The bees can sense this, so when they go to a flower that has a lot of pollen, they can sense the electrical field, and it'll stop and it'll pick up the pollen. If the electrical field is greatly reduced, they know another bee's been there, and there's not going to be much for them to pick up, so they'll skip over that flower and go to the next. The bees have become very efficient at learning which flowers to stop at and which ones not to. And this is one of the reasons they're able to do that. But you can see that the bees get completely covered with pollen sometimes. It's really cool seeing this on the flowers. And then they turn around and they've got these hairs on their legs where they literally scrape it off, and then they can pack it under their pollen baskets on the back legs. They'll mix it with a little bit of honey to make it stick together, and then they keep these nice big pollen pellets on their hind legs. And that's how they transport it back to the hive. A little bit about the flowers, where they get it and how they transport it. the pollen is produced on the anthers and then transported over to the stigmas where it goes down the ovary for pollination to be complete. So the bees will be running around on the anthers collecting it. When they do it, they'll transfer over the stigma and transfer it for the flowers. So it's their movement around on the flowers, not just one individual flower, but flower to flower that turns around and takes care of the pollination. A lot of trees require pollination from one tree to the next, such as apples and almonds. So then the bees, as they're all covered with the pollen, they'll take it from one tree to the next, not just one flower to the other flower. And here's the thing, that flowers produce nectar that has absolutely no benefit whatsoever to a flower. The only reason a flower produces nectar is to turn around and attract a bee to come in and visit it. So that was a symbiotic relationship that they've built over millennia to turn around and help each other out. Some of the flowers produce nectar continuously throughout the day. Others only produce it at certain times. Flowers such as buckwheat, they only produce nectar in the early morning. So if you go to a buckwheat field, you'll see all kind of bees and pollinators out there running around collecting nectar in the morning, come back in the afternoon, and the field will be completely devoid. The bees realize that there's nothing else to be gained there. So they turn around and learn from that. I'm not sure if you're going to be able to hear this one. I'll start over again, but this is a bumblebee on a partridge pea. On the partridge pea, the pollen is held extremely tightly to the anthers. It doesn't just fall off by contact. So the bumblebees have actually figured out they could use sonic energy to knock it loose. So when the bumblebee turns around and lands, you'll hear the noise she's making go up in higher pitch to knock the pollen off. And then when she moves between flowers, you hear her go back to the normal flight mode. So they actually turn around and use sonic energy to turn around and collect pollen. It's really cool when you experience this. This is actually right along my farm lane. And bumblebees also turn around and are early risers compared to honeybees. They'll come out right after dawn, where the honeybees wait until the sun's a little bit higher in the sky and warms things up more. This is one of the first, flowers that bees use throughout the year. As a beekeeper, this is something that we keep a close watch on. When the maples flower, that's the start of the growing season from a beekeeper's perspective. The bees have spent the winter clustered up and just trying to get through the winter on their winter stores. Once the maples bloom, now suddenly they've got pollen available in copious amounts, as well as nectar, that they can start building up the new brood and the young bees. So once the maples start blooming, as a beekeeper, our colonies just start expanding and everything kicks into high gear. So for a beekeeper, when we see the red and silver maples blooming, it's now game on for the next season. People don't realize how important maple trees are to the honeybees and other pollinators, since they're a very early blooming flower. They usually come in here end of February, beginning of March. The bees gathering nectar, they've got a very long tongue, actually, for a small animal. And they turn around and can reach down deep into all the different flower types. When she's done using her tongue, she actually curls it up underneath her proboscis. The other thing you take notice is all these bees here, none of them have pollen on their back legs. If you see a bee outside and she's got pollen on her legs, she's only collecting pollen. The bees, when they're going out foraging, they turn around and are very specific foragers. They go out for one particular item. If they're going out for pollen, it's just pollen. If they're going out for nectar, they're getting nectar. But they don't cross and do both. They also spend a lot of time getting water, which is, people don't realize. The bees have a really amazing way of thermal regulating the temperature in their colonies. In the winter, they all cluster together. The ones in the center vibrate their wing muscles to generate heat, and they keep that cluster at 95 degrees all winter long. In the summer, when it gets too hot, bees actually bring water in, spread it around in the inside of their colony, and then fan their wings to form adiabatic cooling. So they basically air conditioning their colonies in the summer as well. So they do a wonderful job on keeping the temperature between 93 and 96 degrees all year long. But back to the feeding. This is her tongue right down in here. These are other mouth appendages, I should say. And this is actually a drop of honey when I was extracting some in my pole building that this young bee landed on and started drinking. So she has a lot of hairs on the sides of her tongue, so she's basically lapping it up like a dog does. But it's very long, so she can get it down into the flowers to get to the nectaries. When a forager gets done collecting the honey, it's kind of a little unpleasant to describe it. She stores it in a honey stomach. So she basically ingests it, stores it in her stomach, and then when she comes back into the colony, she does not put it into the honeycomb. She'll transfer it to another house bee. And this bee will turn around and take it from her. They transfer it mouth to mouth with their tongues. She puts it in her stomach, and then she'll turn around and go store it in the comb. They've learned how to become extremely efficient at jobs. So every bee's got a different job depending on their age. And when the bees are out foraging, they've become very efficient at just foraging, not wasting time back inside the colony. So they'll come right inside the entrance and transfer the honey over to another bee. Then that house bee will take it to the comb they've built and load the honey into the wax comb. When they build the wax, they use about 8 pounds of honey to create a pound of wax. So they'll have certain bees, their job is simply to ingest honey, metabolize it, and then excrete wax flakes. So it takes them 24 hours to make 6 tiny little wax flakes. So there's thousands of bees in there doing nothing but eating honey and producing wax. And then they'll turn around and with their mandibles, get those flakes and chew them up to soften them and put them in place. And as you can see, the uniformity of their cells is phenomenal. And each one of those cells is actually built at a 17-degree up angle so that the honey doesn't run out when they're filling with nectar. And from one frame to the next, every single one is at identical 17 degrees. Once again, tiny little brain, but they do amazing, amazing things. Question?
So do some of the bees not leave the hive? The ones that are in there doing their thing?
Actually, it's interesting. In the beginning of their life, they do not. I've got a slide to show you their tasks by life cycle. So the bees do not leave the hive until they're basically older, mature bees. So the younger ones have all the jobs inside the hive, and then once they get to a certain age, then they leave. And the very first time they leave the colony, it's called an orientation flight. They've never been outside before. So the first time they go out, they fly out the entrance of the hive and then do like an X pattern in front of it. And they're basically setting their internal GPS compass. So they'll start here and then they'll move back and move back and move back about 10, 15 feet. And they'll do that for about 5, 10 minutes. And they've set their GPS, and now they can go back in. And then from that point on, they'll know exactly where the colony is and where home is. So they can fly all around and come back in. But they only do that in the end of their life. Towards the earlier stages, they do all the internal jobs. And then once they turn around and get the honey dried down to a low enough water content, then they'll cap it with a wax capping. So it's basically like us making canned goods for the pantry. We'll turn around and get green beans or whatever, and we'll process it so it'll be shelf stable. And then once it's shelf stable, we enclose it. They do exactly the same thing. They'll turn around and take the nectar, which is approximately 80% water when they get it, and then evaporate it down so it's about 18% water. That makes it antibacterial. It won't ferment or go bad at that point. They're also smart enough, they add additional enzymes in it so that they break some of the sugars down to turn around and make some mild acids, gluconic acid, which also makes it more antibacterial, antimicrobial, as well as hydrogen peroxide. So they're making this material that's a wonderfully antibacterial compound, and that's what allows it to be stored for such a long period of time. Then as beekeepers, we turn around and when we see it all covered with caps, we know it's ready to go. And then we'll take it out and harvest it for our purposes. One interesting thing about honeybees is they'll turn around and put more honey in storage than they ever need to get through the winter. They're very forward thinking, so they'll turn around and just pack a whole lot of honey in, even though they don't need it all for the winter. So that allows us to take the surplus out and still leave enough for the bees to get through the winter. This is a beekeeper that's got much nicer hives than I do, and they've made it in a real nice garden setting. But each of the boxes has a specific purpose. The bottom ones here, she's got painted red. That's where the bees raise their young, the brood, and then on top of it is where they store the honey. The bees always put the honey on top, above their young brood. We've got a small mock-up here. This is a beehive, just like we'd have outside, just in a smaller scale. Inside each of the boxes is a frame with foundation, with hexagonal foundation markers on it, so to start them with the comb building. The ones in the bottom for the brood are a little bit bigger. And this is where they'll turn around and raise all their young, and then turn around and put the honey in the supers above it. Depending on how much honey they put in, these stacks could get extremely tall. So I've got mine that have reached 8 and 9 boxes tall, which makes it a little difficult to work, but that's a highly productive colony. Because if they're 8 boxes tall, they only need 3 to make it through the winter. So that allows me as a beekeeper to remove 5 boxes for honey production. And this is one thing that every beekeeper will use is a smoker. They're invaluable, and they're just a simple little piece of equipment. We basically start a small fire in here, and it burns very inefficiently, so it produces a lot of smoke. And then it has bellows that we could turn around and pump it, and it just blows the smoke out the nozzle. Bees do a vast majority of their communication with smells. They generate pheromones for all kind of different communication. The one thing that really affects the beekeeper is the alarm pheromone. When they realize there's a problem, there's danger, there's serious issues, they'll generate an alarm pheromone that'll kick off the other bees to start getting concerned. So we turn around as beekeepers, before we open the hive, we'll just puff a little smoke on there, and that interrupts that scent communication between the bees and allows them to stay calm. So if somebody gets upset, they don't trigger the others to do the same. So you always see a beekeeper just puffing a little bit of smoke into a hive, and that's just to turn around and then interrupt their communication so they can't set off an alarm. I was just speaking about pheromones, and the bees use pheromones for absolutely everything in a hive. I'll be touching on it a little bit more shortly, but it's amazing the chemistry that they use for communication. Inside the hive box, it's pitch black all the time. So they don't use vision to communicate. They can't see anything. There's never any light in there. So everything's either done by touch or by smell. As a beekeeper, we turn around and go in and we'll open the boxes up and then pull each of the individual frames out, like I did there, to check on conditions. In this case, my wife Dawn, that's a honey frame right there, so you can see it's all capped. We'll be taking that off. Over here, this is one of my nicely productive colonies. This one has about 90,000 bees in it. And this one's produced 8 boxes of honey already this season. This queen is absolutely phenomenal. I've raised 4 daughters from her for next year to try to get her genetics throughout my apiary. Absolutely wonderful queen. And there's one thing about bees, they're just like houses in a development where every house has a different family and every family acts differently. Each family can have different number of kids. Some can be really nice. Some can have big families, some small families. It's the same thing with bees.
How do you know which one is a daughter?
Actually, I've set it up so that the queens, bees, when they go to raise a new queen, they create what's a queen cell. I don't have a picture, unfortunately. It's a special large cell that a new queen is being raised in. So when they're doing that, I can actually take those and move them to another box to turn around and start a whole new colony. There's typically only one queen in a colony, so if they start a queen cell, the existing queen would normally leave and take half the bees with them and swarm. That's their way of reproduction. So as a beekeeper, I'm kind of short-circuiting that a little bit. And when I start raising a new queen, I just transport her to another box. So it actually looks like a small peanut. Whereas I have some pictures with the, actually coming up next. This is a regular worker brood, and it's nice and flat. If you can imagine something about 3 to 4 times that size. That's what a queen cell looks like. They make her cell much, much bigger. So when we see those as a beekeeper, we could take them and move them and start a whole nother colony. This is what we would do when we're inspecting, just to make sure that everything's healthy and normal in a colony. The center area here is capped brood, so these will be emerging as young bees shortly. Then around it we have larvae, eggs, and then this is a honey band. The bees realize that the nurse bees have to feed the young larva continuously. They have to feed that larva 1,700 times a day because it grows immensely fast. So they've got the honey close by, so the nurse bees here can go up, eat the honey, and then come down and feed the larva as it's growing. Here's a close-up of that. So we have the eggs here that the queen has laid. And then up here, you can see these little C-shaped things. These are young larvae. They're only about 2 to 3 days old. Then down here, they're about 4 days old. And then up here, they're right around 7 or 8, so they're getting ready to get capped. So the next day or so, these larvae will actually giving off a different smell. Right now, all these larvae are giving off pheromones that say, feed me. So that's why the nurse bees will be coming back constantly to feed them. Once they get to this age, they'll give off a different smell that says, stop feeding me, and put a cap over top. And then the bees will come and they'll put this cap, which is semi-permeable, lets air go through. So it's a combination of wax and propolis. So it's kind of like a net rather than a solid cover. And that allows the larva to turn around and completely change form from that little larva, almost worm-looking creature, into a bee. That larva will completely dissolve all its internal organs and rebuild them totally differently as a bee in a matter of days. It's truly amazing. And people ask how big a baby bee is when it emerges. they actually emerge full size. So once a bee comes out of her cell, she's just the size she'll be for the rest of her life. For a queen, any egg can become either a worker or a queen. Only difference between the two paths is how the workers, the nurse bees, feed that new larva. A regular worker will get special royal jelly food for the first 3 days. And then after that, she'll just get regular honey and regular pollen. And if you do that, the enzymes and hormones will turn her into a regular worker bee. If you continue to feed that larva their high nutritional royal jelly, then she'll turn into a queen. So it's amazing that you can go from a worker to a queen bee simply by the nutrition you get while it's developing. How the nurse bees decide which one becomes a worker and which one's a queen, no one quite knows that yet. And then here's the difference between the castes. The worker, the drone, and the queen. The queen and the worker are all female. So 95, 98% of all the insects in that colony are female. The drones are the only males. So basically everyone is doing work in the colony is female. The males are kind of slackers. So the only thing a male does literally is mate with virgin queens. They do not do anything else for supporting the colony. I showed you the mouth parts on the workers, on how they can get the nectar. The drone doesn't have those. Drone can't even feed himself. So he's got to beg the nurse bees to feed him every day. So the only thing they do is mate, and unfortunately if they get lucky, they lose part of their abdomen during that interaction, so they die immediately thereafter. So getting lucky is not so lucky for them. If they don't successfully mate throughout the year, come about October when it starts cooling off, the workers realize that, hey, they've got a bunch of drones in here that are not doing anything for the colony. They literally kick them out the front door so they don't have to feed them for the winter. So they boot them all out and they're gone. So the drones, it's kind of an interesting life. They also do not have stingers, which I take part in World Bee Day over in Cuyahoga County, where we had 1,200 school kids come through to teach them about bees and pollination and everything. One of the cool things we could do, since drones don't sting, is we actually get some drones and put them on their hands and let them pet them. The kids love that. It's really cool. And this goes back to the question we had about timing. From an egg to when the bee emerges from her cells, 21 days for workers. And it is completely and utterly consistent. A worker will come out 21 days after that egg is laid. Interestingly, a queen will come out in 16 days. Since they fed her so well, she develops much faster. So a queen will come out in 16 days, whereas a regular worker's in 21. And then once they emerge, the very first job they get is they have to go back in and clean their cell. So it's like, welcome to the world, go clean up your room. And then they turn around and they start feeding the older larvae, and then the young larvae. And as they get older, they get different jobs. Feeding the queen, building the comb. Like I said, certain bees just turn around and generate wax. So they spend 24 hours basically just sitting still, metabolizing the honey sugars into the wax. Ventilating the hive. You'll see when it gets warm outside, there'll be bees sitting on the front porch, facing outward on one side and inward on the other, fanning their wings. So they'll actually get an airflow circulating through the colony. So they thermoregulate extremely well in there. Once they get a little bit older, then they turn around and leave the hive. And then they go out and forage for the various nutritional materials. If you take notice, 63 days, 9 weeks, that's the maximum worker bee's life is in the summer. 6 to 9 weeks. They literally work themselves to death. In the winter, they can live 6 to 8 months because they're staying in the colony and they're not flying around. I think I've got it on one of the slides further up, but if you get a chance to see a bee stop on a flower and she sits still long enough, look at the back of her wings. If they're nice and smooth yet, then she's still a fairly young bee. If it's starting to get torn and ragged, she's getting towards the end of her life. They literally wear their wings out. The queen is the center of the colony. There's normally only one per colony. Sometimes you can have two, but it's rare. When they're raising a new queen, they'll create more than one queen cell. They'll create 6 to sometimes 15 or 20. But there's only going to be one survivor, so the first one out goes around and kills all her sisters. So it's, yeah, a little intense there in the beginning, but so it pays to be the first one out and not dallying around. And a queen bee also has a stinger. Hers do not have barbs on it. Regular bees have barbs. So when they sting you, it pulls the entire stinger and venom sac out of the abdomen of the bee. A queen does not, so that allows her to sting all her sisters without harming herself. So there's a difference there. The other interesting thing about stingers for a worker bee, there is actually 2 sides to the stinger, and they've got barbs on each side, and their muscles turn around and push one at a time, so that actually drills into your skin, and that's how they get in so quickly and so deeply, and why it's so hard to pull it out. It's a really interesting engineering design. Another thing, just as beekeepers, some people always ask, how often do you get stung? Fairly frequently. As you get stung more repeatedly, 2 things can happen. One, you could become more sensitive to it, which is actually kind of rare. And the other is you become desensitized to it, so the more you get stung, the less it affects you. So now at this point, when I get stung, it's a minor inconvenience. My wife doesn't get stung very often, so when she gets stung, you should hear the 4-letter words. And she swells up, so it's she starts talking about the very stupid bees. Whoops. One thing a beekeeper will do is we mark the queens. We turn around and put a little paint dot on the top of her thorax for 2 reasons. One, over on this side, you can see there's the queen. She's very, very hard to find. Looking for a single insect amongst 50 to 60,000 that look almost the same makes it very difficult to find her. So when we do, we turn around and just with a paint pen put a paint dot on her. Hobby Lobby, high tech. And we turn around and put different colors on each ear so we know their age. So this one was green, so she's 2 years old now. This year's are blue. As I mentor beginners, it's something that I get called frequently to help them to find their queen. They can't find the queen in there. So I help find them, and then we turn around and mark them so they can identify them easily in the future. This one is going to be a video. I talked about pheromones. The queen gives off one very important pheromone, queen mandibular pheromone, that identifies her to all the bees in a colony. So that creates colony unity. The bees are also comfortable because they know they've got a queen. And thirdly, it prevents the worker's ovaries from developing. So that keeps just one queen in the colony. It's not transferred through the air. It's not a vapor. It's transferred by contact. And what you're going to see is all her attendant bees here are going to be rubbing their antennas on her body. So they're actually stroking the queen to pull the pheromone off, and then they'll carry that pheromone throughout the colony to transfer it all to the other bees so they know what the queen smells like. So you can see all their antennas rubbing up against the queen, transferring the pheromone. So it's like absolutely everything in the colony runs off of chemistry and smells. This video here is going to show you a queen laying an egg. She can lay about 1,800 eggs a day. Another question I get asked a lot is, do bees sleep? And the answer is yes. They're like us. They need sleep as well. The foragers, those guys work first shift. They're outside flying during the day, so they come back in and they actually nap at night. The nurse bees that have to feed the larvae 1,700 times a day, those girls are only catching cat naps. So they literally just sleep for a couple minutes at a time and then get back to work. The queen, same thing with her. She's laying eggs 24 hours a day. So she'll be laying eggs, and then she'll get tired and stop, and she'll sleep for a few minutes, and then it'll wake her up, and she starts laying eggs again. So the colony doesn't quite shut down overnight. The foragers all come back in, and they rest, but the nurse bees and queen keep working 24 hours a day. And this is a really cool video showing the queen laying an egg. And when she first went in there, you saw her reach in head first. There she went in and checked to make sure the cell was clean, and checked the size of the cell to make sure it's the right size for producing a worker egg. One of the other things is honeybees are just one of the pollinators. We've got a whole lot of native pollinators out there. And right now the honeybees are getting a bad rap of outcompeting the existing pollinators. That's only partially true. If you turn around and are a commercial beekeeper where you're moving tens of thousands of colonies, yes, you can actually turn around and affect the native pollinator populations. Small hobbyists, we don't produce enough bees to turn around and make a difference. The big thing that's affecting the pollinators is forage and pesticides, which I'll be touching on shortly. But these are just some of the pollinators I saw in the sunflowers yesterday. I just took these photos. We've got a bumblebee in one of my honeybees. Pearl crescent butterflies, they were all over these things. A whole bunch of different little native bees. We have, I believe, 400 different native bees in Ohio. And I'm amazed at how many of them I see. They're just all kind of shapes, sizes, and colors. It's really cool. But one of the points I want to make is this is where I took those photographs, and they're my colonies right there. So even though this is right in front of the colonies, there's still a ton of native bees and other pollinators all intermingled right there. So it's not like the honeybees have driven the other pollinators out. There's enough forage for all of them. To help pollinators, not just bees, but pollinators in general. I'm not one of those people that's like, oh, save the honeybees and the heck with everybody else. Native bees are extremely important to the ecology, as well as the pollinators, the butterflies and moths. So one of the biggest things is forage. They need food. A lot of the stuff we've done nowadays with the farming and our suburban housing is we've eliminated their forage. On my farm, I've turned around and I grow soybeans and corn, normal row crops, and I've got woodlands. So in the woodlands, I've got all kind of native areas that the bumblebees and carpenter bees can all thrive in, as well as a lot of the solitary bees. And then all the intersecting areas, I let natural wildflowers come up. I've got tons of goldenrod coming up now and ironweed and things of that sort that not just my bees, but the native bees enjoy as well. Same thing with nest sites. If you've got perfectly green lawns with no place for them to burrow in, you're not going to get bumblebees. They actually build their hives underground. And this is the big thing, pesticides. That's impacting all the pollinators out there. So that's the biggest impact right there is pesticides. And if anybody's going to spray pesticides, the biggest thing to do is spray it when there's nothing flowering. Because if you spray pesticides and there's flowers, then all the different pollinators are out there, unfortunately, getting side kills from the same pesticide they're using to kill other bugs. This is an area of my property. I put in a wildflower mix, Midwestern wildflower mix. I've got, I don't know, about 8,000 square feet of this stuff. Part of it's for the benefit of the pollinators, and part is I really love flowers. So the neat thing, though, is goldfinches and hummingbirds love this stuff as well. I've got goldfinches by the dozens coming into these patches. It's really cool watching them. And these are all wildflowers that are normal to this area. And this is one big thing that everybody can do. I really hate going through developments and lawns are perfectly green, mowed, uniform, nothing else. Dutch white clover benefits all kind of pollinators, not just honeybees, but all the natives like Dutch white clover as well. People don't realize that Dutch white clover used to be included in grass seed up until the 60s. That was normally what you actually included with regular grass in your lawns. It's self-fixing for nitrogen, so it actually fertilizes the lawn, so you don't need to put fertilizer down. It buries its roots about 6 feet down, so it's drought tolerant. It's a wonderful thing to have in your lawn. Unfortunately, people really don't like dandelions, so they put herbicides on for broadleaf plants, which also kill all the clovers, which is a real unfortunate occurrence. I've actually overseeded all my lawn area with Dutch white clover. I haven't fertilized it now for, I don't know, 15 years. It works real well. And the dandelion for honeybees, that's an extremely important flower. Our season for brood ring starts with the maples, and that's when they get a bunch of pollen and nectar coming off the trees to get started. But when they turn around and get to the dandelion season, that gives them a huge boost of pollen, and that's when the brood rearing really kicks into high gear. So the bees absolutely love dandelion. And then milkweed, another thing that we have unfortunately lost a lot of in Ohio, as well as everywhere else, and it's affecting not just bees and other things, but the monarchs. I've got a whole stand of milkweed I've planted in my place, and it's amazing, all the native bees, the honeybees, and the monarchs that are coming in. I turned around and had a bunch of them lay eggs this year and get caterpillars. It was really cool watching that. But that's something that everybody can do to turn around and help out the pollinators. Along the woodlands and edges, these are considered weeds by people. This is goldenrod, native to Ohio. The pollinators all love it. It's just absolutely covered with native bees as well as honeybees right now. Same thing with ironweed. Real pretty purple flowers, about 5 feet tall. The bumblebees are just crazy about that stuff. These are plants that normally get cut down because they're considered weeds. So native wildflowers are a really wonderful thing to help pollinators. So one of the big things to do is don't spray pesticides when plants are flowering. That is the biggest way to kill off a lot of unintentional pollinators. If you do it in the evening when they've all gone back to their nests. So that way it'll be absorbed into the plants and not be out and active when the bees and other pollinators are present. And if you could turn around and leave if you have dandelions or clover in your lawn, if you can let that lawn grow just a little bit longer before you mow it, so that the flowers bloom, that really helps them out. The Xerces Society has a lot of good information on pollinators. So if you're really interested in following up with the pollinators, those guys have a lot of good information. So basically, if you can grow any bee-friendly plants, trees, things of that sort. People don't realize trees produce a ton of flowers. People ignore trees when they're thinking about it, and they only think about planting flowers, but trees have a major impact. Black locusts, tulip poplars. Tulip poplars are an amazing plant for pollinators. They produce a huge amount of nectar. And basswood, of course, all your apple trees and blackberries and things of that sort. Bees also produce propolis. It's kind of like a construction adhesive they use in their colonies that has an amazing antibacterial function they use to turn around and keep their hive free of disease. They get that resin from poplar trees. So there's a whole bunch of trees that actually benefit bees and other pollinators. As I said, the dandelions and clover, if you can get them in your lawn, that really does a lot for the various pollinators. The other thing is plant for continuous bloom. A lot of times people put plants in and they'll just flower in the spring. If you can get ones that flower in different times through the season, then you basically give them food throughout the entire year. The end of summer, there's a thing called a dearth. Basically, all the spring flowers have faded away and the fall flowers haven't started. That's a really tough time for all the different pollinators. For resources, there's a Ohio Bee Identification Guide that goes into all the native bees, and there's literally hundreds of them. And some of them are really cool iridescent colors. It's just, the various types are just phenomenal. I've lost count of how many different ones I've seen on the property. And then, of course, native plants, rather than invasives. A lot of this stuff that's being sold in the nature centers, plant stores, look real pretty, but they don't benefit pollinators so much. The natives do a much better job on that. And then the Xerces Society has a whole ton of resources for helping out pollinators. They're a great, great society. And if anybody's got any questions, I missed that, getting that slide in here. The two basic food sources. One is the honey, which is their carbohydrates. So that's what they eat as sugar for their carbs. They also collect pollen, bring it back, and they pack it in the cells alongside the honey, and that's their protein source. So they'll actually mix the pollen coming back in with a little bit of honey and some enzymes, and they ferment it in the cells, and it's called bee bread. But that's the pollen that's the protein source for the bees. So those two foodstuffs makes up their entire menu. And the pollen, if you ever, you're probably not like me, but watching bees come in, they have different color pollen on them. Each of the different flowers has different color pollen, and each pollen has different amino acids and different amounts of minerals and vitamins. So if you look in a beehive, you'll see that the pollen cells are all different colors because they're getting in from the different flowers. So that gives them a very balanced diet. It's really amazing. The dandelions have a very balanced amino acid mixture in their pollen. So the dandelions are actually very important for the health of the bees. Sunflowers have a reduced amount of amino acids, so they're not covering the entire health spectrum for the bee's diet. But it's interesting because they've got a strangely shaped pollen structure. So when it gets in the bee's gut, that actually helps kill off bad bacteria inside the bees. So the pollen from sunflower is actually very beneficial to their health from that perspective. The maples, that pollen comes in very early, so that's important. So all the different combinations of flower pollens add up to a completely healthy diet for the bees. It's amazing.
The birthing of these bees, are they proportional male to females, 1-to-1?
No, it's grossly one-sided. It's about 98% female. They only have a couple of hundred drones in a colony because they only need a relatively small amount to go out and mate with the virgin queens, whereas they need the females to do all the work. So,
But the birth is not 1-to-1.
no. And the way that it's controlled, the queen actually controls the sex. If she lays a fertilized egg, they'll turn into a worker, a female worker. If she lays an unfertilized egg, then it'll turn into a male drone. So in that video, when you saw her putting her front legs in and checking it, drones are much larger than the workers. So if she can feel it's a big cell, she knows it's a drone cell, and she'll lay an unfertilized egg to turn into a male. If she finds it's a regular, normal-sized cell, then she'll lay a fertilized egg and it turns into a worker. Yeah.
What about hive collapse? You have mentioned, is that still an issue and Africanized?
Yeah, the hive collapse, in times past, colony collapse disorder occurred. This winter, I don't know if you guys heard on the news, but the commercial guys lost like 65% of their colonies this last winter. Well, they just finished a study in what actually happened. Bees have a parasite called a mite. It's almost like a bee's version of a tick, which causes enough problems on its own to the bees, but they also transmit about 27 different viruses to the bees. So basically, they're making the bees very, very sick. And the treatments that the commercial guys use to control the mites, it turns out the mites developed a resistance to it this year. So their treatment systems didn't work. They didn't kill the mites, and the bees got a lot of viruses, and they didn't make it through the winter. So that's why they lost so many. As a sideliner beekeeper, I don't use those kind of chemicals. I use organic natural acids. The mites have not developed the resistance to it, and it's a natural material. Works very, very well, but it's a lot more time consuming. So the big commercial guys weren't doing that. They took the easier way out by throwing a chemical in there. Whereas if you turn around and keep to the natural organic acids, it's still a very effective treatment. So.
You said the queen bee lays about 1,800 eggs a day and then takes little naps for rest. Does she mate frequently with drones in order to keep enough fertilized eggs?
Very good question. Actually, she only ever leaves the colony once. She's born, and then she'll turn around and fly out on her mating flight. And she can mate with between 6 and 20 drones. And and she'll collect the sperm from all those various drones, and actually holds it in a special sac called a spermatheca. So it all gets mixed up in there. So she turns around and gets millions and millions of sperm, takes it back, and she uses that to lay eggs the rest of her life. So she only mates that one time, multiple times, and then stores all the sperm. And the interesting thing is, by mating with multiple drones, she's mixing up the genetics in her offspring. So if she only mated with one drone and it wasn't a good one, her colony would die. But if she mates with 20, she's got 20 different bloodlines going. So.